Hello everyone and welcome and thanks for joining me today. My name is Killen and this session is titled Insufficient Facts Always Invite Danger, Captain. Spock has probably caught your attention and needs no introduction. He's all about logic, truth and staying informed. So we're going to be taking a look at how to monitor Sitecore containers to stay informed on the performance of our environments. For those of you who don't know me, I'm a technical director at Valtech. I've been in this industry for over 20 years, with the last 8 years dedicated to Sitecore implementations. I had the honor of receiving my first MVP in 2019 and again this year. In this session, I will look at why we should monitor containers, some industry standard tools, how to monitor your host OS and Docker. Then I'll show you how to instrument Sitecore, Solar, and SQL. I'll briefly discuss some other metrics that you might be interested in, how we can handle alerts, before finally wrapping it up with a look at where we go from here. Why monitor containers? Starting a new Sitecore project. The team and myself decided to adopt containers for development. We didn't want to use containers in our higher environments until we had more experience and felt confident with the technology. During development, I found myself asking the question, what are these containers doing to my local instance? The processor is always churning. How can I monitor their performance? Unlike VMs, the ephemeral nature of containers makes them more challenging to monitor and requires some different tooling. But as I discovered, using containers provides some fancy new tools. These tools allow you to create a monitoring platform that has the potential to observe pretty much every component in your resource in your stack. We can create stunning dashboards that look impressive like these for your colleagues, or should I say, your kids when they pop over to see what it is you're working on in this quarantine life we find ourselves in. And we can use the same monitoring platform for all our environments. It no longer has to be something that is reserved only for production. Ultimately, having sufficient monitoring of our containerized environments, we hope to prevent an enterprise disaster. Now let's take a look at some industry standard tools. When I first started thinking about how to monitor containers, I considered using InfluxDB and Grafana, having already used both of these with JMeter for monitoring load test results. However, I quickly discovered there was a tool called Prometheus that was dominating this space, so I had to find out why this tool was so popular. Prometheus is an open source monitoring tool, written in Go, originally built by the folks at SoundCloud. It was the second project to graduate from the Cloud Native Computing Foundation after Kubernetes. This provides some guarantees in terms of the quality of the code base, maturity, and stability of the platform. So you might be wondering, how does it function? Prometheus works on a pull model, which means that your application only needs to expose metrics, and Prometheus does all the heavy lifting. It will periodically scrape those exposed metrics and store them. Let's take a closer look at some of its components. The Prometheus server consists of many internal components that work together, enabling it to periodically collect and store metrics in a time series database, ready for interrogation. Exporters are used to extract information from your application, translate it into the Prometheus format, and expose it on a HTTP endpoint. The challenge with the pull model is that it needs to know where to collect metrics. Service Discovery solves this problem and supports common services like Kubernetes and Swarm. While the pull model is predominantly a pull-based model, it does provide a push gateway, as not all applications are suited to a pull model. Prometheus also has its own user interface and allows you to query the scraped metrics using its own query language, PromQL, written specifically for time series data that it collects. Having defined alerts in Prometheus, the Alert Manager handles the sending of notifications to different channels. While Prometheus has its own graphing feature to visualize metrics, it's not as feature-rich as, say, Grafana. Through its API, we can consume metrics in other applications. Now let's take a closer look at some of its components. Prometheus has 4 metrics. The counter can increase in value and reset when the process restarts. The counter can increase and decrease, and it is useful for things like CPU, memory, threads, and active requests. The histogram and summary are both similar in that they sample observations and collect these in buckets, and these are useful for averaging the observed values and typical things like your request duration or response size. Spinning up an instance of Prometheus is straightforward with Docker, although it is a Linux container, so you need to enable support for both Linux and Windows containers in your Docker engine to run it locally. Prometheus uses a YAML configuration file that allows you to define the targets you want to scrape, how they should be scraped, and the frequency. Prometheus also provides an example configuration showing you how it can scrape itself. It's that clever. The easiest way to start Prometheus is with a simple Docker Compose file, where you define the image, map a few volumes, one for the location of the configuration file, and the other to persist the metrics data it collects. When you run Docker Compose up, you can verify Prometheus is running by hitting the localhost port 9090. You should see the Prometheus expression browser, and this allows you to interrogate the metrics that have been scraped. Another useful view is the target status. This allows you to check the status of your configured scrape targets. Grafana also runs in Docker, so you can easily spin up a containerized instance alongside Prometheus. Grafana supports Prometheus, so you can access it as a data source and write queries in PromQL and create stunning dashboards for your metrics. Grafana also provides some pre-built dashboards that you can download for several of the exporters, which then can be imported into Grafana. Grafana version 5 introduced the concept of provisioning. This allows you to automate the process of adding Prometheus data source to your dashboards, and it makes perfect for running in a container and persisting everything. Using the same compose file we created earlier, we can add Grafana and set up some map volumes, one to map the configuration to provision our Grafana instance, and the other to persist the data that is captured. That's the foundation of our monitoring platform. Now let's explore some various targets that we might want to scrape. The host runs many containers. To have a true perspective on the health and performance of your containers, you should also monitor the host as well as those containers. Now, when I first started looking at the different tools and explorers that were available, a lot seemed to center around monitoring Linux containers. While these tools work very well on a Linux OS, they don't work as expected on Windows. Node Explorer, for example, is a popular tool for obtaining Linux-based OS metrics. However, if you're on Windows, then I suggest you run something like WMI Exporter, also known as Windows Exporter. CAdvisor is another exporter that aggregates metrics from your running containers. There is a comparable Windows version called CStat Exporter. Now let's take a look at how you might instrument Windows host using WMI Exporter. WMI Exporter is available on GitHub and runs as a Windows service and exposes metrics on default port 9182. It can be used to monitor a range of Windows services and components, including IIS and SQL. Once installed, you can verify the service is running and the metrics are being exposed, ready for scraping on localhost port 9182. Now we can configure Prometheus to scrape the host metrics target. By adding a new job, we just need to define the IP and port and specify the scrape interval. WMI Exporter includes a Grafana dashboard. As you can see, this provides a nice overview panel of the host, including the processor, RAM, CPU, memory, and disk usage. In Docker 1.3, they introduced an experimental feature to expose Docker engine metrics for Prometheus. This provides all the key metrics you need to monitor your containers. There are metrics covering the engine, the containers themselves, and in swarm mode, there are additional metrics about the cluster. You just need to update your daemon config to enable this feature by specifying the metrics address. After you restart Docker, you should be able to browse to the Docker metrics on localhost port 9323/metrics and verify the metrics are being exposed. Once you confirm it is running, you can configure the target in Prometheus. We can check the status using the status view to verify there are no issues scraping our Docker engine. There is also a Docker engine dashboard available on Grafana that you can import. When it came to instrumenting Sitecore, I wanted a simple exporter that could be added to each Sitecore container that could expose .NET and system performance metrics. Things like number of requests, requests per second, memory, CPU, and garbage collection. Ideally, the same performance counters that Sitecore writes to the logs. Obtaining these metrics is pretty straightforward with the .NET System Diagnostic Performance counter class, but I needed to be able to export these metrics in the Prometheus format. That's where Prometheus Net comes in. This library helps you instrument your .NET apps and expose metrics in the Prometheus format on a HTTP endpoint. It supports .NET Standard and .NET Core and provides examples to show you how to get started instrumenting your applications. So I built Spock Counter Exporter, a simple exporter that uses Prometheus.NET library. It reads performance counters and transforms these values into Prometheus format and exposes it on an endpoint. Different counters can be configured via configuration, so you can easily add or remove counters. I also created a simple script that accepts the name of your container, copies it to your container, and runs it. Alternatively, you could include this in your Docker image. Once it's running, you just need to configure Prometheus and add the new script target, and then verify on Prometheus that is able to script the Sitecore target. I've also created a Grafana dashboard showing the number of requests and the requests per second, CPU memory, garbage collection. The typical info you might want to monitor. I don't know about you, but Solar has always been a bit of a black box when it comes to troubleshooting performance issues. So I was interested to see what metrics I could instrument for the Solar container. Solar has actually done a lot of work in this area and provided some APIs and made metrics available. You can access these within the console, I think from version 6.3. This exposes a plethora of performance-related metrics, but they're not in the Prometheus format. Again, I needed an exporter. As it turns out, there is a Solar exporter created to consume these Solar metrics and output metrics in the Prometheus format. Fantastic. In Solar 7.3, they actually incorporated this as a contributed project. So if you're running Sitecore 9.2 or above, you already have this exporter sitting in your container. It just needs to be enabled. It also exposes metrics if you're running in Solar Cloud. Yes, Jeremy, it is fascinating. To run the exporter, you just need to run the Solar command in your container, passing in a few parameters. But I've simplified it further by creating a PowerShell script that simply accepts the name of your Solar container and starts the exporter for you. Once running, you can verify that the metrics are exposed and ready to be scraped. Now you can add the job to Prometheus to scrape the targets and verify that it is running. Solar also includes a fairly comprehensive Grafana dashboard. You can see we're able to monitor the heap size, memory, and threads, more metrics from Solar than you could possibly hope for. We can also instrument the SQL Server container. There are several exporters already available for SQL to choose from. They either obtain their metrics from the SQL performance counters or from querying SQL Server directly. I like the possibility of being able to query SQL for performance metrics, as this allows the opportunity to run Sitecore database-specific queries to retrieve information such as the number of items or the event queue and publish queue to ensure that agents are tuned properly. While you can run exporters within the same container, some exporters can run as a separate container. I believe this is known as a sidecar container, a container that helps you monitor an application container. You can add the SQL exporter to your Sitecore compose file and configure the SQL performance queries in a JSON file. Typical SQL performance queries could include things like deadlocks, connections, index sizes, and fragmentation, and query performance stats. We can then update the Prometheus configuration file to scrape the SQL exporter metrics and verify that it's being scraped. This particular SQL exporter also includes a Grafana dashboard that we can just add to our Grafana instance. So we've managed to spin up an instance of Prometheus and Grafana and script information metrics for our host, Docker engine, Sitecore, Solar, and SQL. What other metrics might we be interested in? Well, we've not touched our application running Sitecore. It too could be instrumented to expose metrics. If it was, say, a transactional site, you might be interested in monitoring the number of transactions or the number of exceptions. If it was running, say, an ETL process like Data Exchange Framework, we could monitor and expose metrics on the speed of that transformation or the error rate. We could also monitor other parts of our stack. There are exporters already available for things like Redis Cache, JMeter, or even Google PageSpeed, allowing you to build a monitoring platform with all your metrics, performance-related metrics, in a single location. Grafana dashboards are great for monitoring metrics, but ideally, we want to know when there is a potential problem. Alerting with Prometheus is separated into two parts. Alert rules are defined in Prometheus. which basically is a configuration of a threshold on a specific metric. When that threshold is reached, Prometheus will trigger and send an alert to the alert manager. The alert manager then manages the distribution of that alert to the correct channel. These channels could include things like email, PagerDuty, or even a Slack channel. Hopefully you saw Rob and Bart's session on containers and Kubernetes, and you're feeling ready to take your containers to the next level. Prometheus is capable of monitoring containers in Kubernetes, and I'd like to help you get started. Monitoring your containers with a simple kit and some examples. The Sitecore Performance Observation Container Kit, aka Spock, and it will be available on GitHub soon. Thank you. I hope you've enjoyed this session, and live long and monitor.
Another great session at Sitecore Symposium, and we are live here with Neil. Thank you for your presentation, Neil.
Thanks, Tomas.
So it's really exciting. All these things, I think many of us really need when we do a Sitecore solution.
Yeah.
But first of all, maybe just the first question: what will be included in the Spock kit? Right, will be available.
Okay, so I want to make it really simple, and I find it a bit of a challenge when I was getting started. So I want to make it easier for people to get started with monitoring their containers. And so what's going to be included in there is the Grafana dashboards that you see. There's going to be PowerShell scripts to get started, and then also the Spock counter exporter. And I've been working on some additional scripts just to make it the whole process a lot easier, because as you find, it seems to be a lot of configuration to, I want to configure Sitecore container, I want to configure my Solar container, I want to configure my SQL container, and lots of steps to go through. So what I've been working on is a PowerShell script that will actually take a look and see which containers you have running, and it'll check the image that those containers have been built off of, and then actually instrument those containers specifically for the type of container that they are. So if I'm running Sitecore XP locally, it's going to install the Sitecore container, copy the Sitecore the counter exporter into that container, and it's going to start it, and it's going to check and make sure that it's running. And then it will do the same for Solar, and then SQL hopefully as well. So things like that, to make it really easy to get started, just so you can take it for a spin.
Absolutely, but you mentioned that you had some kind of challenges. What were those challenges when you started getting this monitoring?
Yeah, so I mentioned it in the slide deck, and that so a lot of the material that's out there is all based off of Linux containers, and so just getting started and trying to find some information about how to monitor Windows containers or containers running on a Windows platform was quite challenging. And there's lots of, even some of the posts that are out there, some of the material that's out there, it even suggests, use CAdvisor, use Node Exporter, use these on Windows, but they will run, but the metrics that they actually expose aren't necessarily correct. You need to be monitoring, if you're running Windows, you need to be running the Windows Exporter and things like that. So just be careful what you're reading. But there's a really good book which I'd recommend. This one here, by a guy called Brian Brazil. If you want to get started in Prometheus. Okay,
and how will this Spock kit help developers to get started monitoring containers?
Well, like I said, they'll just have to check it out from GitHub, and there'll be an initialized script which they can run, and that will hopefully it will instrument their containers and get them up and running, just so they can get a feel for running Prometheus, try and get their head around Grafana if they've not used it before, and just help them understand better what's involved in monitoring containers, at least for their local environment. And then we'll hopefully add additional scripts when I start looking at moving it to Kubernetes and Swarm and things like that.
All right, so the next question is, if Docker needs more monitoring, that isn't it more disadvantage than just using it as standard virtual machine?
Of
course, it's not directly about the content you just presented, but in general.
Well, that was the challenge I found, right? Is, monitoring a VM is really easy. You can jump on the VM, you can fire up perf1, but that's not available to you. But I think what you'll discover is that these tools that are available, they provide you with an advantage in that you can, because how many of us will, we only monitor our environments when we have a problem. Whereas if you set up a monitoring platform and developers set it up locally, then that gives them an advantage of they know what it looks like to monitor their environment locally. And as they move up the stack, so they'll have their QA environment, their dev environment, the QA environment, and stage in production, they'll have the same monitoring tools, the same dashboards available in each environment, which gives them a huge advantage. And also, as they're developing, if they make a change, so say they introduce a solar query which impacts solar, has a dramatic performance hit on solar, then they can see that issue early on in the development process rather than wait until it actually hits production. So I do see it as yes, you may need additional tools, but I think these tools are beneficial and not necessarily a negative thing.
Okay. The next question is about security. You mentioned all sorts of ports being open and watching to or listening on different ports, this and that. Is it like a security concern, or it shouldn't be a problem?
No, I don't think it's a problem at all, because you have the same security advantages of running in a container. So your monitoring platform is going to run in the same container space, same network as your other containers. So it's you get the advantages of running containers that they provide in terms of security. So they'll all be within the same network resource, although you can bridge between different containers. But yeah, you'll probably spin up a network and a network resource which would have your Sitecore containers, and in that same resource you would also have your monitoring platform as well. So your Grafana and your Prometheus containers will be in that same resource.
Okay. And you mentioned that some of the platforms already provide out of the box some kind of exporters to Prometheus. Yes. And so on. What is the biggest difference between how you can export these information from like a Sitecore instance than any other platform?
So right now, I think, and Prometheus doesn't provide any of the exporters. They're mostly written by the community, Prometheus community, and on their website there are 163 different libraries and exporters available, and they're continually being added to, and that's just what's on their website. Other people are creating other exporters, but the particular one that I used for Sitecore was a .NET library, and there are libraries as well that allow you to create your own exporters that support different languages, so .NET, C#, Go, and Java, things like that. And so by using one of those libraries, I was able to create my own exporter because there isn't one for Sitecore. So hopefully the one at the moment, it's pretty agnostic in terms of application. It will monitor a .NET application and pretty much any .NET application, but that's not to say that could be extended to also expose Sitecore specific metrics. So the counters that Sitecore currently writes to the counters directory. And I know previously they had to be installed, but I think they come out of the box now and they're enabled and they can be disabled. But they could easily be exposed and imported into our script, should I say, by Prometheus too. I didn't find any real challenge by creating that library. Pretty straightforward, and there's material available on how to do it too.
So this also means that the Sitecore export is the 164th community contribution from you, or?
Yeah. And okay. And you can also, sorry, and you could, so I've created a console application, and that will, at the moment it's .NET Framework, .NET Standard, but it could also be .NET Core, so for Commerce Server and things like that, things that are written in .NET Core. And then also, I mentioned the application, so the Prometheus.NET library as I said, it helps you instrument your own applications as well. So you could expose application business related metrics, which would be very beneficial.
And Sitecore has an official Docker image provided with version 10.
Yes.
But would this Spock solution work with the community images, what was released for Sitecore 9 and so the earlier versions?
Yeah, so I've tested it on 9.3, and I'm going to do some more testing on the earlier versions, and then I'd like to take it for a spin on Sitecore 10 as well before I release it to the community. Yeah, but I don't see there being any problems with it running on 10.
Okay. Do you have any expected date for the release?
Good question. Hopefully sometime in November, if not sooner. But yeah, watch this space. It will be available soon. I just got to do some more testing on it and streamlining it as well. So, there's lots of scripts included in it, but I just want to make it really simple and straightforward. You just run initialize and it'll take care of all the work for you. Yeah.
I think the next question is,
yeah. And one thing, it's out, because obviously the Sitecore 9 images, you have to build them yourself, and there's a little bit involved in building those images, and when you're want to take monitoring and try it out and test it before you actually add that as part of your image, and that's ideally what you would do. Okay, I'm happy with Prometheus and this tool set, and this is what we're going to use going forward. You would then include this tool, whereas at the moment I'm copying the utility into the containers. So ideally you would just have it included as part of your build of the images.
Okay, we got a really good question from Jason. Thank you for your question, Jason. Are you looking for any beta testers or community contributors to your project?
Yeah, that's a great idea. I'd love to have some people help out and test it and obviously take it for a spin and give some feedback. So as soon as I make it available on GitHub, I'll reach out to the community, let them know it's there, and hopefully gauge some interest in people that would be willing to take it for a test.
Okay, well, do you have any contact information where people can find you?
You can reach me on Twitter, LinkedIn, and I'm on Slack as well. So all the usual Sitecore community channels.
All right. We have 2 more minutes for the questions. So if you have any more questions, please use the question box on the right side to send some more questions. And maybe in the meanwhile, we get the next one. Could you please, just explain, how did you get to the point that, these kind of things, or how did you get to Prometheus, and, what was the process when you started the whole project?
Yeah, so obviously I would be on, spinning up XP and containers locally, and I'd be on calls with the team, and, I get, Neil, what is that noise in the background? I'm like, that's my machine. It's just running really hard, and, the processor's constantly running, the fans are running. And when I shut down the containers, and some of the developers on the team as well would have some performance related issues too, and most of it was down to memory. These were in the early days, when they realized, hey, you need 32 gigs of RAM to be running containers. But it kind of struck me, and the project we're working on as well, we talked about it would be great if we could have this in the higher environments, but we need to be able to, understand what these containers are doing, and if we run into an issue. But so I wanted to know, what are these containers? How are they performing locally? What impact are they having on my machine? And what is each individual container doing? How can I monitor the performance of it? Having ran into issues in production and other environments, I want to try and understand how could we do that, so we could have confidence when we do take it to a higher environment that we'll be able to monitor and understand and troubleshoot issues if they did arise. So that's kind of where it came from. Yeah. Okay,
you mentioned that it started all with performance issues, and Rob is asking that running this solution on a production environment could cause any performance issues, or just monitoring is completely detached from the system?
Well, Prometheus and Grafana itself, they're going to run in separate containers. But I think one thing you would need to be careful of is probably your scrape interval, right? Because that's going to be hitting a web service that you would expose, and so you would need to keep an eye, obviously, on that. So if the frequency of those, the scrape target is something that you'd want to look at. If you're running extensive SQL queries and you're monitoring your SQL instance and you're running those, very very say every 30 seconds, that's probably not recommended. So that would be something you keep an eye on. But Prometheus, in terms of its stability and its capabilities, I don't think there are any concerns there. I mean, this is running for some big environments currently, and it handles. It's capable of handling a lot of metrics and monitoring a significant amount of containers at the same time as well. And it's scalable as well. You can have multiple Prometheus instances running at the same time, aggregating all those metrics in a single place. So.
Sounds really good. Thank you for your presentation again, and hopefully we will see your solution soon on GitHub.
Thanks, Tomas. Thanks, everyone.
Thank you, everyone. Bye-bye.